All right, this one will be real quick. This is sort of some extra knowledge of current stuff that's not going to be heavily focused on in this class, but it's good to know. So another type of current, we mentioned at the end of the last video that the main type we're going to focus on is called DC, which is direct current. But another type you should know is AC, which stands for alternating current. In this case, the electrons reverse, they alternate the direction that they are flowing. This is the type that is in your walls, actually, not coming from a battery, and ultimately a generator somewhere, either maybe in your garage if the power goes out, or at the power generating station, there's a generator making that alternating current. By the way, if you open up a circuit, if you disconnect the wire anywhere, we say it's open, then the current stops flowing everywhere, essentially instantaneously. So that would be an open circuit there. Few things you should know about current in the US. Our outlets are ultimately connected to generators. So at the power plant, generators at the power plant, so they are alternating current. The standard voltage in North America is, we say 120 volts, although depending upon how you define it, you could say 110 volts, but that's often what we say. And since they're going back and forth, they're actually switching direction quite rapidly. They're doing that 60 times per second. So we could say the frequency of electricity in North America is 60 hertz. It's not the voltage that gets you. We mentioned that with the balloon video earlier, or the balloon portion of the video. Even though you have high voltage, that doesn't necessarily mean that it's dangerous. It normally does. It's actually the current that gets you. So at 0.001 amps, 1 milliamp, we could say, you can feel that amount of electricity. At 5 milliamps, it starts to get painful. At 10 milliamps, you'll start to have your muscles contract. And then at 70 milliamps, it could kill you if you got it through the heart. So it's the current that technically gets you, not the voltage. But when you see a danger high voltage sign, don't think that physics is wrong. High voltage, all other things being equal, corresponds to high current there. Um, a few other safety things here. Let's talk about some devices here and what keeps you safe in your house. So first of all, almost every plug you have will have these two flat plugs here, but some things may have this third plug. What is that third plug about? That is the ground plug. So if something goes wrong with your microwave oven and a wire breaks off inside and touches the body of the microwave oven, if we didn't have this ground plug, then that electricity would be sitting up there at high voltage, waiting for you to come and touch the body of the microwave and give it a ground that we talked about last week. And so it would flow right through you. What this does is ensure that that doesn't happen. It takes any of that excess charge and it dumps it literally to the ground. Somewhere outside your house is a wire just going straight into the ground to dump that excess charge. Another safety device you'll see in many things is called a fuse. So a fuse's job is to protect the circuit, the machine or whatever, from too much current. It does that with this little wire here. When the current gets too high, this little wire here will melt, and that breaks the circuit, we say. It opens up the circuit, and the current will no longer flow. There's fuses in your car so that you don't destroy the computer in your car if something happened. Here's a working wire, and here is one that has gotten too high and melted. We say that we have blown the fuse. In an old house, there might be fuses inside your house that protect the circuits in your house from too much current. And then those would have to be replaced when they blew if you ran too much electricity. Those are all almost never used these days anymore. You probably have something in your basement. You should go down and check it out, called a breaker box. It has the same basic function. It breaks the circuit. It opens the circuit up. The advantage of a breaker box, why they're better than fuse boxes, is that they can simply be switched back into place. So there's a little switch in here. When the current gets too high, it flips the switch and opens up the circuit, and you can go back down if you were running like your microwave and your garbage disposal and your vacuum cleaner all at the same time. That might draw too much current, and to protect your wires from overheating and catching fire, then it would just flip the switch. Last one here is you may see these in your bathroom or something because of hair dryers. Same basic concept right here. It's called a ground fault circuit interrupter, but it's a little mini circuit breaker put into the switch. And so it switches off when you draw too much current in there and protects the wires in your house from catching fire from drawing too much current. That is the end of electric current video part